Next generation.
Okay, so this is the Okapi 2 circuit board kit, and this is the Okapi 2 wiring kit, and today I'm going to show you how to connect the circuit board kit and the wiring kit to make a fully functioning Okapi 2 system. Okay, so inside the wiring kit you have a number of wires, a number of receptacles and a number of sensors. Two sensors for each solar collector unit, one for the inlet, one for the outlet. You also get three receptacles, which I'll show later. You get two extension wires. These run up to the inlet at the top of the solar collector, where you'll place one of the temperature sensors inside the receptacle there and inside the inlet. And you receive two outlet and fan wires. These come pre-assembled, I should say semi-assembled. You have the contacts, the female contacts there on one end. The other end, it's basically up to you to cut this to length, strip the insulation, and then solder that into the circuit board kit. Then you have two of these wires, because the Okapi 2 will drive two solar collectors. Okay, so with the Okapi 1 circuit board, this board actually comes with 4 extra thermistors, just in case you want to do the wiring yourself. Again, the wiring kit is optional. If you have the wire, if you have the skills, go ahead and do that wiring yourself, and it does come supplied with the four thermistors. You need to mount one in each inlet and one in each outlet of each of your solar collectors. Okay, and here's the Okapi 2 circuit board. You will see there are a number of holes. You have 2 holes here for each fan. That's for the plus 12 volts in the ground for fan 1 and for fan 2. You have 2 holes for each of the temperature sensors. So here is outlet number 2, inlet number 1, outlet number 1, inlet number 2. The PWM for the variable fan speed control holes are F1P for your fan 1, goes in conjunction with fan 1 here, and F2P, which goes in conjunction with fan 2. So basically, one solar collector you could call solar collector number 1, and you'll connect up fan 1 and fan 1P, inlet 1 for the temperature sensor, which is IT1, and outlet temperature sensor 1, which is OT1. For the second solar collector, you will connect fan 2, so that 12 volts on the ground, fan 2 PWM, your outlet thermistor connects to OT2, and your inlet thermistor connects to IT2, inlet thermistor 2. On board we have quite a sophisticated microcontroller for the Okapi 2. This one is actually capable of communicating on a serial port. I'm going to do another video of that later. Unfortunately, the Okapi 1 version does not have that ability. There's simply not enough memory on board that chip. Okay, we have 2 relays, one to control the power output to each of the fan. We have a 3 amp fuse on board that's already mounted for you if you want to take power from a battery for this, a 12 volt battery, perhaps connected to a solar PV panel. There is a voltage regulator. There is a little bit of spare power in there if you need to tap into that for any reason. 5 volt regulator. You have your LED light here, which gives you error codes. I'll go into that a little bit later, but the board will tell you if it detects any hardware errors, specifically with any of the temperature sensors, and it'll tell you exactly what it thinks is wrong with them. And otherwise, that's pretty much it. So let's do the connections. Okay, so first of all, we're going to make up the 2 wires. So again, you would cut these wires to length. They actually come in 3-foot sections, so depending on where you're going to mount the circuit board itself, you'd want to consider how long you want these wires to be. They do need to be able to connect to the fan, so really the shortest connection here is to the fan. The next longest connection is the outlet temperature sensor, and then finally you would use the extension lead to rig up the inlet temperature sensor, so that one isn't too much of a worry. But these are both 3 feet long, so you want to consider what length you would want these, running them between the circuit board and the outlets of the solar collectors. Anyway, so after you've trimmed this to length, just take some of the outer insulation off nice and gently. You don't want to nick any of the wires inside. There we go. And once you pull that insulation off, just check around those internal wires for any nicks. We'll do the same with the second outlet wire, connecting wire. It'll take about 2 to 3 inches of outer insulation off there. And then again, just check around for any nicks on the wires. If there are any nicks there, the wires could snap later on or cause a short circuit. And then you just want to go through and strip each of the 7 wires. This is a 7 core wire with 22 AWG. That's 22 AWG wires inside. It's more than sufficient to handle the power output to the fan. We'll go through and strip the insulation from the 22 AWG wires in the second outlet wire. Okay, we'll just clean up the mess here and solder those wires onto the board. Okay, so we'll do the control wires for solar collector number 1 first. So it's just a case of locating all of the ones, F1, IT1, OT1, F1P, and putting the correct wire in the right hole. So we're going to start here with the black wire. Again, the wiring kit is optional. You might find it a lot easier to use this wiring kit because our instructions pretty much go with it. But if, like I say, you're competent with wiring and soldering, you have the wires available, and there's no reason why you can't do it yourself. So again, the black wire wants to go in. I'll try and show you that the left hole, as I'm holding it here, on F1. Let's just pump that through. And now do the orange wire into F1P and then solder those 2 in. That will hold the whole cable in there nicely for when you put the rest of the wires through. Okay, the solder I use typically is this lead-free, no clean rosin core 0.02 inch gauge. It's pretty easy to work with. I know a lot of people don't like using the lead-free, but if the gauge is fine enough, it shouldn't be too much of a problem. Okay, I'm just going to solder in that PWM wire and the ground wire to fan 1. Just make sure you get the pad and the lead at the same time. There we go, and that's pretty much the hardest part done. Now we just need to, see, I cheated with a bit of tape there to hold the wires in. Everybody has their own techniques. I find that works well enough for me, or use the helping hands. So now it's a case of feeding through the remaining wires. So your red wire is the 12 volt power supply for the fan. So that goes into F1. You can see that there. Next to the black wire you just soldered in. It goes in there. You want your white and green pair. They are for the outlet, and your brown and blue pair are for the inlet. They're not polarity sensitive, so it doesn't matter. So you want to feed in your brown and your blue into inlet 1, IT1 whole pair. There we go. And again the white and green pair, they go into the outlet, so OT1 for the solar collector number 1, which is powered by fan number 1. So just feed those through. You can see because you did the black and the orange, the PWM there first, the other wires are held nicely in place, but you can use your tape or again whatever method you find easy to do that. So I'm just going to flip that over and solder those in place. And there we go, looks good enough. I'm just going to trim off the excess leads there and check the work. Okay, so those leads are trimmed, so I'm now going to insert the control wire for the second solar collector. So same as before, we just want to go for the ground wire first, the black wire. Solder that into, as you see it there, the hole on the left for fan 2 or F2. Now we're going to do the PWM wire. Now this hole is all the way on the other side of the board, so just next to the LED there. So again, the orange wire controls the PWM, pulse width modulation. Just going to hold that cable in there with the tape, just makes it a bit easier when I'm trying to do the video. Okay, so that wire is now in place, so we can go ahead and thread all of the other wires in. So we're going to start again with the red, with the 12 volt for fan 2. It goes on the hole on the right on F2. Now we've got the outlet number 2 working from left to right here. It's next to the barrel for the power supply. So the outlet is always the green and white pair. Doesn't matter which order you put them in, but for the sake of neatness I'm going to copy what I've already done on the board for heater number 1. So thread that in place, so green then white for OT2. And we're left with the brown blue pair for inlet number 2. So again that's IT2. I'm going to go with the brown first just to match up with the brown blue for heater number 1. So thread that in, put my magic tape over there, and I'll solder all of those connections in place. And that is that. Let's clean up the soldering iron and I'll trim the leads and we'll talk about adding the connections. Okay, at this stage it's probably a good idea to test the board. The power supply that we prefer to use, we actually sell this with the full Okapi system. That's where you basically get the Okapi. The circuit board is already wired, it comes with the box. Comes with all the connections, everything's already done for you. All you have to do is install it into the 2 solar collectors. We sell this unit, it comes with the Okapi 2 system sold in the United States. The reason I like this unit is that it comes with over voltage protection as well as short circuit protection. This unit, Triad WSU 120-2000, gives 2 amps of power through to the board at 12 volts, which is more than enough for the fans that we supply and prefer to use with this board, as well as the operating current for the board itself. So let me just go plug it in and test the board. Okay, so plug it in. What we're looking for is the light to come on just one time. That is a a lamp test function. So whenever you, let's do that again, whenever you plug the board in, the lamp should blink just the one time, just to say that the LED is working. And then it's going to blink a number of times because it's determined that there are no thymistors added. So you count the blinks when you have a problem like this. The unit actually, when it detects an error code, it'll switch off the relevant part of the circuit. So for example, if your inlet thermistor on heater number 1 is shorted out for whatever reason, it'll actually shut down heater number 1, but it won't affect heater number 2. Heater number 2 will continue to work, and vice versa. If there's a problem with heater 2, it'll shut down heater 2 and heater 1 will continue to work. So only the blinks, you count them. There is a reference sheet that is up on our website and also in the instruction manual, and that'll tell you exactly where it thinks the problem is. Not only where it thinks the problem is, but what it thinks the problem is. Typically it would be a thermistor which isn't connecting for whatever reason, or has shorted out, perhaps because it's touching the inlet vent in the solar collector. But very, very straightforward to troubleshoot with this unit. Okay, so that all works. So now I'm going to wire it into a box. Okay, so this is the box kit that you can purchase from our website. Again, it is optional. Just we've chosen this box because it is constructed to protect circuit boards, and the circuit board is designed to fit this box. So it just makes the installation nice and easy. It comes with 2 mounting flanges as well as a sturdy lid. Okay, so the lid comes with the 4 bolts to secure it in place. You'll also find with this box we have 2 spacers to rise the front edge of the circuit board off the board. You can glue those in place if you require that, and 2 small M3 bolts to screw the board in place. So to mount the whole unit together, again, this is assuming you have your own power supply and you've done all the wiring. So we're going to undo this nut and remove the rubber band which holds the wires tightly in place. Get the 2 sets of control leads from the Okapi board and pass them both through the nut and the rubber band. Just move that up the wire out of the way. Now we pass all of the wires through the cable gland itself. Listen gently to make sure you don't bend anything. And there we go. Now we're going to get the power supply lead and pass that back through the cable gland as such. And then get the rubber band, push that over and slot that into place, and then the plastic nut, push that over the power supply barrel, and we're going to screw that in a little bit. And pull the control wires through. Okay, once you pull those through, you can plug in the power supply. So this is the tricky part, basically, because this power supply has, I think, a ferrite cores there just to prevent any electromagnetic interference going back up into the main circuit. So what you really have to do is, if you're using this box and this setup, just tighten the cable gland as much as possible. That right, and then at the same time just get as much lead through for the power supply as you possibly can. And that'll just bend around. I don't know if you can see that in the camera, but the end will just bend around in there, and it just basically locks everything in place. And if that works, then the mounting holes should appear just above the lugs. So it looks good. I'll now screw those in. Got the 2 M3 screws that come with this box. That's 1 and number 2. 2. Screw that in place there. And then there are the 2 spacers which you can mount under the front edge of the board if you like, and just glue those in place. Just using the bent needle nose pliers to get those under there. There we go. Once they're in place, you just straighten them up and just put a drop of glue in there if you like, just to keep them in place. And that's pretty much it. It's nice and secure. Tighten that gland up as much as possible. That will basically trap the leads in place, so if anything does pull on them, the wires should be secure. Okay, so then it's just a case of putting the lid on and screwing that in place. So now all we need to do is attach the receptacles onto the control wires. So what you'll find with each channel, with each heater kit, that you get two 2-hole receptacles and 1 3-hole. The 3-hole is for the fan. Each of the 2 holes are for the thermistors. And you get 2 of these for an Okapi 2, basically because it controls 2 heaters. And the 2 thermistors there. Okay, so starting with 1 control wire, the first control wire, I'm going to get the red, the black and the orange. They'll go together. That's for the fan. And I'm going to get the 3-position receptacle here. You'll notice that there is a triangular shape on one end and a square shape on the other. With the triangular shape, we just make sure the red goes through. We have the black, the ground in the middle. Squeeze that all the way in, make sure it's nice and tight. And then the orange, which is the PWM, goes into the square end. And then for each of the thermistor pairs, so we have the brown blue, which is the inlet pair. Again, this isn't polarity sensitive, these are not polarity sensitive, so it doesn't matter which way this connects up, but with the receptacle there is a triangular end and a square end, but it doesn't matter which way around it goes. So just push the brown blue pair into that receptacle and make sure it locks in place. And then you have the white green pair, and again, doesn't matter which way around, so we'll just put that into one of the 2-position receptacles. And that's that one finished. Now, because this is the outlet, all we have to do is put the thermistor, the temperature sensor, directly onto there. That just slots in place. And this you'll wire directly behind your fan. So you want to take this into consideration when you're setting up the whole system. This needs to be inside the vent, at the bottom of the solar collector, right behind the fan, so it can sense the temperature of the flowing air coming out of your solar collector at floor height. And then we get the other control wire and basically do the same. So again, it's red, black, orange. And they go into the 3-hole receptacle. Again, on the triangular end, you want to get the red in there, black in the middle. Red is the positive 12 volts, the black is the ground, the orange is the PWM. Let's make sure the orange goes into the square end. Then you get your brown-blue pair, and they go into a 2-position receptacle. Doesn't matter which way around, which is in the triangle and which is in the square hole, doesn't matter. And then you get your green-white pair, and again, doesn't matter which way around, just push them through into the 2-position receptacle. Then you get a thermistor, which is already mounted into the male receptacle there, and just plug that directly in. So that's all set. That just needs to be mounted behind the fan on your other solar collector. And then you have your 2 extension wires. So we're just going to, on this female end, mount another thermistor, and that goes, just drop that directly into the inlet so it can sense the temperature of the air flowing through that. The other end of the wire plugs directly into the brown-blue pair, and so. And then your final extension wire, you have one end which plugs into the brown-blue pair, and this goes into the inlet on your second solar collector. And then finally the thermistor, which you will mount inside the vent on the inlet into your second solar collector. And that's pretty much it. That's a good point actually. Just watch out for some of these contacts coming back out of the holes, especially if you're doing all the wiring yourself. Sometimes when you push them in, it might force the contact to unlock and pull back out. So just go through and double check that all of the contacts are, none of the metal is showing. And then all that's left to do is plug in the fans, and you can test the whole Okapi system before you mount it into the solar collector. Alright, so I'm now going to test this unit. I have a fan kit here. Again, fan kits are available on our website. Of course, you can use any 12-volt variable speed fan that you like, providing that it doesn't exceed the 4 amp specification of the circuit board. But just bear in mind the whole of the Okapi system it's really designed around a 4x8 feet or a 4x10 feet solar collector. So it's really that is the ultimate in its design. That's what it's specified for. Now it can run solar collectors which are smaller or larger, and you can add whatever fan you want as long as it is to specification. Again, a maximum draw of 4 amps at 12 volt, and it needs the PWM signal. However, this is the fan we've chosen. This is the fan we sell with the fully assembled Okapis. A couple of reasons we chose this fan. It has a very good static pressure rating, which means if there is airflow impedance inside the solar collector, it should do a good job of overcoming that, and that just means that it won't be too detrimental to the CFM output of the fan. This fan is rated at 110 CFM. So again, that's pretty much ideal for a 4x8 or a 4x10 solar collector. If your solar collector is larger, you might need a little more, you might not. If it's smaller, this fan should still work. It's the Okapi system continually monitors the temperature and adjusts the fan speed accordingly, so it should work for a smaller collector, but you might want to consider using a lower rated fan. Also, this fan is reasonably quiet compared to some of the other fans that we've tested, and it is quite a powerful fan. Otherwise, it is only 12 volts. It looks small, but it does kick out 110 CFM. Included with the kit, you do get a finger guard and the nuts and bolts to attach the finger guard. Please attach that. Okay, so I'm just going to connect this fan to one of the control wires. Just make sure the wires match up, the 12 volt, the red, the ground, which is the black, and the orange and yellow, which is the PWM signal. I have another fan here which has the finger guard already mounted, and connect that up to the second control wire. There we go, so the red, black and orange yellow match up. And we can plug the unit in and test it. So the first test I like to do is just to locate one of the white blues. So this is the outlet sensor, and if you just pinch the thermistor, the associated fan should come straight on and start revving up. We'll find the second white-green pair. So the outlet for the second solar collector. Let's pinch that thermistor, give it some warmth, and the fan immediately starts to rev up. So basically what this is doing is, because I pinched that thermistor, it determined that there is a temperature rise between the inlet and the outlet, sufficiently enough to turn on the fan and start revving it up. And there we go, both fans have now wound all the way down and switched off. You heard the relays click. They'll wind down very gradually. That should help with the life of the fan as well. So that's pretty much it. Another test you can do is actually put a hairdryer or a heat gun for momentarily onto the convection sensors, which would be you're going to install these in your inlets in your solar collectors. So this is a second method of starting the fan. This is actually the usual method of starting the fan. This inlet sensor, will detect convection, and as soon as it detects sufficient convection, which can be between 80 Fahrenheit and 95 Fahrenheit, it'll switch the fans on for a time duration, and then once there is sufficient heat going through the solar collector, the outlet temperature sensor should be sufficiently warmed up to then take over control of the system and independently operate each of the fans on a variable speed, which is reasonably proportional to the heat inside the solar collector, plus all of the determinations that the Okapi system itself has made about previous weather trends to say if it's warming up or cooling down or whatever it thinks is going to happen next. And there we go. Thanks for watching.
Next generation.